Hello and welcome back. In our last tutorial, we had learned the basics of deductive logic and Venn diagrams. In this tutorial, we are going to learn how to solve syllogism questions using the concept of Venn diagrams. So we'll pick a fairly simple question to explain the concept. So even if you think the question is not difficult, please bear with me as I want you to understand the process of solving it. So this is the typical structure of a syllogism question. You are generally given between 2 to 4 statements. These are nothing but premises that we discussed in the last tutorial. They are followed by some conclusions, again varying from 2 to 4 in number. And then on the basis of the statements, we need to find out which of the conclusions can be inferred, and so we mark our answer accordingly. So let's try and understand this. Let's just concentrate on the statements first. So these are the two statements. Let's try and make their Venn diagrams. Let's pick the first statement. All cars are trucks. Now there will be two cases. This is the first one. So in this figure 1.1, this circle denotes both the cars and the trucks. So this is cars as well as trucks. Means all the cars are trucks and all the trucks are cars. The two sets are equal. And this is the second possibility. If this is cars, trucks would be bigger. So in this case, all the cars are contained within trucks, but there are some trucks that are not cars. So these are the two cases that we studied last time. Now look at statement 2. No vans are cars. This is a simple one. We know that these are disjoint sets. So it will be drawn like this. So in this case, no cars are vans and no vans are cars. So there is absolutely no intersection. So these are the three figures that we have to summarize the two statements. The reason we draw Venn diagrams is that once we draw them, we don't need to go back to the statements again and again. So this comes in handy when the statements are complicated and involve more than 2-3 sets. So the data becomes easier to interpret. So now when we have drawn these figures, we don't need the statements anymore. So we can remove the statements safely from the screen. The current screen is enough to tell us what was written in the statements. Now as we know, 1.1 and 1.2 are the two possibilities from statement 1 and 2 is the only possibility from statement 2. But to arrive at the solution, we need to club these two. So let's first combine 1.1 and 2. We'll call it case 1. These are cars and trucks given in 1.1. If we have to combine it with figure 2, vans would be drawn like this. Obviously, since there is no intersection between cars and vans, there will be no intersection between vans and trucks as well. I hope that's understood. Now let's try combining 1.2 and 2. Look at this. This is the same figure that's given in 1.2. Now the only restriction with vans is that it cannot overlap with cars. So we can put vans here. So this is fine, but that's not the only possibility. Look at case 3. Again, this is the figure given in 1.2 and let's put vans now. Again, this is also possible. In this case, as you can see, there is an intersection between trucks and vans. Means some trucks are vans, but it still does not violate any condition given in the statements. And that's not all. There is a fourth case as well. We can put vans inside trucks. So basically in this case, all the vans are contained within trucks. But this is fine with us since this also does not violate any condition given in the statements. So basically the combination of 1.2 and 2 results in 3 cases. Case 2, case 3 and case 4. Now you need to understand this. The two statements that were given to us in the question give rise to these 4 possibilities. The 4 cases. Case 1 where cars and trucks are the same and vans are different. There is no overlap. Case 2 where cars are contained within trucks and there is no intersection of vans either with cars or with trucks. Case 3 where cars are within trucks, obviously they have to, but there is some intersection between vans and trucks. But there still exist some vans that are not trucks. And case 4 in which all the vans are contained within trucks. So both the cars and the vans are contained within trucks, but cars and vans are still disjoint sets. I hope the 4 cases are understood. Once we have made this, we don't need the figures 1.1, 1.2 and 2. So let's remove them and bring back the conclusions and the answer options. This is it. Now let's see which of the conclusions follow. 1. No trucks are vans. Now this is possible but this is being violated in case 3 and case 4. So this is not a certainty. So conclusion 1 does not follow. You have to be absolutely clear about this. We would say that a conclusion follows only if it follows in all the cases, because all these cases are possibilities only. Since we can see that there is an overlap between trucks and vans in cases 3 and 4, we cannot conclude that no trucks are vans. Look at 2 now. All vans are trucks. Again, this clearly does not follow. It's being violated in case 1 itself. So let's cross this. Number 3. Some trucks are vans. Again, this is also violated in case 1. So this also does not follow. Number 4. Some vans are not trucks. Now this is a good one. Case 1 is fine, case 2 is fine, case 3 is also fine. So there are some vans that are not trucks. But if you look at case 4, all the vans are shown to be trucks. So again, this does not follow because of case 4. So let's cancel this as well. So it means that options A, B, C, D cannot be the answer. So the answer has to be option E. But let's try and understand what it says. We have been asked to mark E as the answer if either conclusion 1 or conclusion 3 follows. Now understand this very carefully. Look at conclusion 1 once again. It says no trucks are vans. We can see that this is the situation in case 1 and case 2. And if we look at conclusion 3, it says some trucks are vans. So this is valid in case 3 and case 4. Now there are just 4 possibilities: case 1, case 2, case 3 and case 4. So either conclusion 1 would follow, it means case 1 or case 2, or conclusion 3 would follow, means case 3 or case 4. So we can say that conclusion 1 and 3 amongst themselves cover all the 4 possibilities. Yes, they do. And that's why E has to be our answer. I hope that's understood. So that's how we solve syllogism questions using Venn diagrams. I explained this simple question in much detail because I wanted you to understand this concept. Otherwise, a question as simple as this one can be done mentally without needing any Venn diagrams. We actually need Venn diagrams when the questions are more complex, contain 4 or 5 sets, and data is difficult to handle mentally. So in the next tutorial, I'll pick up some difficult questions and discuss the shortcuts to solve them. But this tutorial would still remain the primary requirement. So make sure that you understand this. The next few tutorials would be dedicated completely to problem solving. But to understand it fully and to feel comfortable, make sure that you have gone through the first 2 tutorials very carefully and understood every single thing I told you. I'll see you soon. Goodbye.